What's up guys, this is Ronnie. Welcome back to our channel Total Technology. So this is the first series on 2020. So as promised, I told you guys we are working on some really interesting and unique topic for 2020, and as promised I just presenting start what do you say, like start presenting this series from now onwards or today onwards. So this is going to be Rust programming tutorial or comprehensive or complete tutorial on Rust. So 90% of you will be kind of like not familiar with what is Rust and what type of programming language is this. So that is why we choose this programming language. So if you go in search in YouTube, there are multiple channels are working on JavaScript, Swift or Android or Kotlin on Flutter or probably Node or React, many things. Okay, and just because we started with Python, so that time I told you that our channel and our topics will be completely unique. We're not going to deal with all the common or like common use cases which is already covered or available in the YouTube, because anyways if you want to learn something, there is no matter whether you watch my channel or other channels, if you are getting the proper matter or proper tutorial, your purpose will be solved, right? So that is why our intention was to create something unique and something actually helpful which is not available within the YouTube community or at least in the other like programming forums. So yeah, definitely we'll get some Rust programming tutorial. There are multiple tutorials are available, but as I told you, this tutorial will be comprehensive. For example, if you take example of our Neo4j report lab, there are tutorials are available in Neo4j report lab, but our tutorial is one of the comprehensive. So this is not like I'm doing self-marketing, I'm just trying to explain why we choose Rust. And the second important reason for choosing Rust is this is a system programming language. I'll come in that part later, what is system programming language, but just remember this thing. System means something which is embedded within the device or within your peripheral, like input output device or any system. For example, your microphone, your watch, or your printer, or your probably your smart if your kitchen is having some sort of smart equipment, that as well having some sort of device driver or program written or running inside that devices. So all those sort of coding or programming actually done using system programming methodologies. So for one of the popular system programming language is C or C++. So Rust is also comes under that category. So it is kind of a system programming used for a system programming language, but again there are some other things which is called web assembly. Rust is also very much used in that area as well. So I'm not going to discuss about web assembly at this first introduction, or rather we can do it in the advanced topic when we are going to deal with or finish more than 20 or 25 tutorial. That time we'll cover that thing, but this is just because the introduction or introductory part, I'm just giving you a rough or brief overview of what is Rust and why we are choosing Rust. So one reason for choosing Rust, there are not very or not much comprehensive tutorial or material available. Second is this is actually very much used in all the system programs or system programming purposes. And now if you say why system programming is that much important, so there is a survey by Forbes, or I'm not sure whether Stack Overflow or Forbes. So it was they predicted that within the year of 2022, so there will be more number of IoT devices available, and the number will be larger than the count of mobile phones. For example, if suppose you're in your family, you are having 5-member family, at least everyone is having one mobile phone. But some of the cases it is very much natural to have 2 mobile phones, because most of our are working people and we are having our official phones. So ultimately if you take the average number, 1.5 mobile phone per person. Now in year of 2022 or 21, the number of IoT device will be the same. Like every people or every family member will be having one at least responsible for at least one IoT device. Okay, just because the number of IoT devices increasing, the architecture or the ecosystem to build, connect, or maintain those ecosystem, we need solid programming or solid like memory management efficiency with respect to like concurrency, with respect to parallel processing, with respect to fast processing, and other sort of things. For example, cyber attacks, memory management, buffer overflow, exploit, all the things. So that's why Rust or system programming is going to be like biggest or toughest job for this decade. Okay, I'm not talking about Python or data science, that is always will be there, but IoT and other device or device related programming and embedded programming will be the future defined like thing for our next decade. So that is why Rust. So now more or less mostly 80% of the devices are using C, C++, or some of the cases Java as well also used for their system programming. But when I say Java, don't judge me, it's kind of a different way I'm talking about. Let's say some of your device is directly connected or integrated with cloud, so for that purpose probably core Java, some other parts are being used or written in Java, but 90% of the devices are being still used on C and C++ because of their fast efficiency and other stuff. Okay, now what is Rust? Okay, so Rust is a system programming language focused on safety, especially safe concurrency. So that is the most important thing. So C and C++ doesn't support that. When I'm saying doesn't support that, probably some of you will start judging me, but no, this is not like that. Definitely they support, but programmer or the coder has to do some sort of additional or add up some sort of additional mechanism. They had to do something more, or they have to put some more effort to make it safe with respect to memory management, with respect to concurrency and parallel processing. Okay, Rust is more or less syntactically same to C++, but it is designed to better provide better memory safety while maintaining the high performance. So in C and C++, if you want to produce or if you want to achieve parallel processing or concurrency, you need to definitely work hard. But with respect to Rust, there are some built-in features or methodologies are available. You should adapt those features, it will definitely help you. Okay, so those part is going to be discussed when we start writing the codes and all. But why Rust? Why the need or necessity for a new language, and why people start learning this thing? Okay, so Rust was originally developed by Gredon Hore at Mozilla Research. So he was an employee of Mozilla and with contribution from other colleagues. So this is actually copy and pasted from Wikipedia. Definitely you guys can go and check, and there are multiple stories of the use case or the actual project documentation is also available. The designer defined the language while writing the servo layout of the browser engine and the Rust compiler. So the compiler is free and open source software, dual license under MIT license and Apache license 2.0. So this is normal. Rust has been most loved programming language in the Stack Overflow developer survey every year since 2016. As I told you, so it is becoming or gradually getting like attention from the programming community. Nowadays more or less all the big companies that are producing IoT devices are also start using Rust. For example, Samsung, Vodafone, actually I'm in Europe, so Samsung, Vodafone or other companies are also start using Rust. So I saw this thing that program has a big prospect and future prospect in the market, so why can't we start developing some sort of material for the community? So that is the reason for that we start building this course and coming up with this course in 2020 as our brand new or our signature tutorial. Okay, so what is system programming? System programming language is a programming language used for system programming which gives direct access to the underlying hardware or peripheral device. For example, you are having your mobile phone. So when you are accessing your mobile phone, you have to write something or you have to type something. Let's say if you are typing something, some message or some phone call or something like that, you are giving some sort of command to your device, and internally that device will interpret and do the actual calling. So when you give some sort of command, your device will get the command and interpret to the hardware and generate some sort of output. So there are two types of programming. One is application programming for the end user or for the application. One is device level related or embedded programming, which will be always residing within the device. Like normal user will not have any access. Access means not normal user will not get the like look and feel or any sort of like influence to that thing. Okay, so that is called system programming. I'm just giving you, like, I know I am giving very bad definition, but I'm very bad at that because I never read those theoretical part. I'm just giving you the high level context, so definitely you guys can go and search from the Wikipedia. So this is something like that. Let's say if you're having one iWatch or any smartwatch, it is showing something, right? Let's say your heart rate or something like that, but this is not like that. So when it is sensing something, it is doing some sort of like operation or calculation. After that, it is displaying something in the screen, rendering. So when it is sensing something directly from your body or from your wrist, so there is some sort of mechanism is happening. So how this is happening, right? So it is directly actually linked with the sensor which is put inside the iWatch or any smartwatch, right? So how the sensor is working, what will be the workflow, how the center data is getting read, what is it like going to be generate some sort of analog input or output? Definitely many other things are actually being processed, written, or like performed with respect to this system programming language. So that is why system programming is that much important. And as I told you, IoT is going to take over or going to like announce themselves like the same way which like mobile phone did like 20 years back. When mobile phone or smartphones came, people thought those are actually not like going to use smartphone. Like it's not like that. Let me put in a different way. Like when the smartphone came or Android phone came, people thought only like the guys or the girls, those are actually very much tech savvy, are going to use smartphones. Like, but that is not the case. Nowadays everyone is using smartphone, whether he is tech savvy or he is not tech savvy, it doesn't matter. The same thing now, IoT is actually completely highly sophisticated thing. Only the tech savvy people are thinking, oh, this is something like rocket science. But after 2 or probably 1.5 years later, you will see you are also responsible for 1 or 2 multiple IoT devices. So for that, the system programming or like embedded programming is going to be very critical. Until and unless you are having solid like base or background or solid the solid conceptual like paradigm for building the ecosystem for IoT, your whole architecture for IoT things or device will completely crash, because hacker can attack your system. Any attacker can like damage your company reputation. So now companies are investing a lot of money to develop this like highly sophisticated and same time highly safe and secure like ecosystem for this IoT thing. For example, in Vodafone is also investing a lot of money. IBM and Nokia, Siemens or Ericsson, both like big companies are already start investing. In India, Microsoft and Reliance is also jointly working to develop this IoT ecosystem. So there are multiple examples. If you are reading the Business Insider or some other like business journal, you will get the much idea about that. Okay, so system programming is for operating system, device drivers of all kind, file system, database, codes runs in every IO device or device must be externally reliable, cryptography, media codec, media devices. So there are multiple things. If I can take millions of names, it will come. Okay, so I'll definitely upload this slides, but I'm not going to read each and everything because I already explained. This is what is system programming and what is concurrency, because in our definition something called concurrency. So I'll explain you why Rust is important. In computer science, concurrency is the ability of different parts or units of a program, algorithm or program to be executed out of order or in partial order without affecting the final outcome. Suppose your program consists of 5 different module or sub-modules. Okay, so concurrency is a mechanism or is a facility that all the 5 modules should run parallelly without impacting each other, and the final output of the performance should not be impacted. So in that way, let's say you are working on a project and 5 guys are working together, and you are working in a project where 5 guys are working. After like once finishes his job and second person will start this job. So definitely when the project is executing with everybody is working parallel, that time it will get the highest like efficiency, and it will get the desired output in much more faster time. So this is how it is concurrency. So this allows for parallel execution of the concurrent units. As I told you, parallel execution means concurrency, which can significantly improve the overall speed of the execution. So this is the high level and the midpoint of the actual thing. You need to deliver your job fast and most efficient way. Okay, So that is why the multi-core, octa-core, dual-core processor speed or computers are here. Okay, in more technical term, concurrency refers to the decomposability property of a program or algorithm or the program in order to independent or partially order components or units. So this is highly technical things, but again, it means if you have multiple unit within your program or code, concurrency means they should run parallelly or partially as a unit. Okay. So what is memory safe? Memory safe is a state of memory safety is the state of being protected from various software bugs or security when dealing with the memory access, such as buffer overflow, dangling pointers and all. So guys, I just took it from Stack Overflow or Wikipedia. I don't know, I forgot actually, because it was a old slide which I used to develop for this tutorial. For example, Java is said to be memory safe because runtime error detection checks the array bounds and pointer. Suppose in Java you wrongly or mistakenly define some array or boundaries for array and all, so in runtime everything will be managed. But in C or C++, arbitrary pointer arithmetic pointer implemented as direct memory address with no provisioning for bounds checking, thus potentially memory unsafe. So C and C++ you need to do by yourself. You need to put some additional effort to manage your memory properly within the program. And this IoT device are very small, small in the sense like they are not having memory of 80 GB or 200 GB, because they're actually should be fit inside some very sensitive device or probably some big devices. That is not the point. But sometimes they are very small and solve fraction of memory management or some like miscalculation of the memory arithmetic or pointer arithmetic can cause the whole system like down, and the company will lose millions of dollars. So that should not be the like expected behavior. So that is why the Rust or the programming language should be efficient enough to do or support parallel processing, fast processing, as well as same point of time it should support the safe memory management. Okay, so that is the reason for Rust. So guys, so I think I have give nice lecture on this introductory video on Rust. Sorry, I'm saying nice, but I know it's kind of like theoretical and dry, but I thought I should do it, or else it will be not relevant if I start doing the download of the Rust and start doing the compiling of the code. So I just gave you a small background or introduction. So from the next tutorial our actual fun will begin. So I just give you the small overview of the next tutorial. So next tutorial will be going to talk about how to download and install Rust. So how to set up the VS Code plugin. VS Code means Visual Studio Code. I think all of you are familiar with Visual Studio Code. So if someone is not familiar with that, I will tell you how to download and install. It's very simple. And for Visual Studio Code, we have a plugin for Rust, how to set up that. Then how to initiate the project using Cargo. Cargo is a kind of equivalent to Python pip. Python has a pip package package or what do you say, like kind of a module which is actually help to do some sort of like packaging, installing and configuration. So in Rust we have similar equivalent thing that is called Cargo. How to run your code using Cargo, how to build your code using Cargo, and how to release your like package for the production deployment, or how to create the binaries using Cargo. We'll also see that. So there is a spelling mistake. So that's all guys, that's all for today. So I'm super excited to start the next tutorial. Probably tomorrow I'll start with the download and installation of the Rust. So gradually we'll like pick up the syntax and as well as some other parts very slowly. But don't worry, just like Neo4j, I will teach you from the basics to advanced. So I will cover each and every concept, and in between if you find difficulties or problem, any question, doubt, you definitely try to write me email. You can reach me out via like YouTube comment or Facebook page comment, whatever. And also those are actually watching this course from Udemy, for them also guys, you can always communicate me via Udemy community or like tutorial forum, whatever is there. I don't know the name actually. And also you can send me personal message. I'll always active over there, so I can definitely try to answer all your question. So special thanks to all of you guys for supporting us in 2019. So 2020 will be much more exciting and challenging for all of us. Challenging means we'll get much more challenge from learning perspective. We'll come up with much more like advanced topics. So definitely I will try to improve our quality as well, because the more you will get new contents, you need to like maintain your quality as well. So that is why we are nowadays uploading videos very slowly and not like last year, like randomly. We are not uploading, we are just following structure. For example, many of you suggested to create some sort of slide and GitHub repository for the course, so we are doing this. So if you have similar suggestion for us, you can always reach us out. We'll try to improve our quality. So enough of talking, guys. I know this is a very dry tutorial, but don't worry, I'll try to improve the material or this Rust tutorial with some coding from the next video. Definitely there will be coding, because all of you know, like my all videos are with coding only, and hands-on. So I'm just ending this video, so hope to see you in the next video. Till then, take care, goodbye, and don't forget to subscribe our channel, hit the bell icon so that you should not miss any notification. And as well, if someone is watching our channel for the first time, please do subscribe to our channel, and also try to share our videos with family, friend, or whoever is interested to learn new topics. Okay, so that's all, guys. That's all for today. Hope to see you in the next video. Till then, take care, goodbye, and have a nice day.